Hey guys, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you have not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem is construct quad tree, very easy problem. We are given a matrix n cross n, so it's a square matrix which has zeros and ones. We want to represent this grid with a quad tree. So we are given a grid and we have to represent that grid in a quad tree. So it's clearly clear from the name. So we have generally binary trees, right? So binary trees means there will be two children. But here there is what? Quad. Quad means four children. So here each node will have four children. Okay. So return the root of the quad tree which is representing the grid. So now let's understand basically how this tree will be represented. This quad tree is a tree data structure. Each internal node has have four children. Okay, so as I said, there will be four children, and also each node will have two attributes. One is the value. Generally, we have value only, but here there are two attributes, which is value. That is the value of the node. If one, then it means true. If zero, it means false. Is leaf is the second attribute, which is if it is true it means the node is a leaf node, and if it's false it obviously it means that it's not a leaf node and it has four children. Okay, so this will be the structure of this quad tree node, that it will have value is leaf, and there will be these four pointers which will be representing the four children. These will be four children. We'll understand what top left, top right, bottom right means. So let's understand here within with this test case. I have taken this test case here, which is this one, second example. So see, basically this grid is given. Okay, this grid is given to us. Grid is given, and we have to convert this grid into a quad tree. So when I am saying we have to convert it into quad tree, we have to return the root of this tree, root of the tree. Okay, so how we can convert this into quad tree? See, in the problem they have given that, see these points, if the current grid has all the same values, if like let's say you, this is the current grid which we have, right? This is the current grid. If this current grid has all the same values, which is not obviously, but let's say if this grid has all ones, then what we have to basically do is we just need to create a node, quad node, right? Quad node we will create. Its value we will set to the value which is there in the grid. So if let's say all ones are there, so value will be 1. It will be a leaf node because all the values are same. So if all the values are same, is leaf will be set to true. So if is leaf will become true, and all these pointers, bottom, top left, top right, bottom left, bottom right, will be null, will be set to null. Okay, this is a case, this is a first case where all the values of the grid are same, whether the value can be 0 or all the values can be 1. So if all the values are same, we will make value as the whatever value is there in the grid, is leaf will be true, and all the four children will be set to null. This is first step. But as we can see here, right, in this problem we do not have all the same values in the grid. So that means that we will have to create a node. So what we will do in that case, we'll have to create a node. This will be the root node, and this root node will have a value. It will have a value, it will have is leaf, and it will have four pointers basically, which will be the pointers to the four children. And what four children will be there? This grid will be divided into four parts. This grid will be divided into four parts. This is the first part, this is the second part, this is the third part, and this is the fourth part. That is top left, this is the top left, top right, this is top right, bottom left, bottom right. Okay, so we will be dividing this grid into four parts. What will be the root value? Let's see that. So if all the values in the grid are not same, then it will be divided into four, like it will have four children. The root will be the node. So here see, If the current grid has different values, set a value to any value. So here value, just set it to anything, 1 or 0, your wish. And is leaf will be set to false, because is leaf will be true if all the values are same. Since all the values in this grid are not same, so the root will be having is leaf value as false. Now the question arises, what will be the pointers here, what will be the values for these four, these pointers, top left, top right, bottom left, bottom right. So here, so if you see guys, see here, this is a bigger grid which we just saw. This is a bigger grid, and when we have to find the children, those will be smaller grids, right? These are smaller grids. Mechanism will be same only, right? For example, let's say I am finding for top left. I have to find for top left. So what I will do, this is my top left. I will see whether all the values in this grid are same or not. All the values are same, or 1 1 1 1 1, all values are 1, right? So I will make a node, that is quad node. That quad node will have value as what? Value as 1, which is the values in the value in the grid. Is leaf will be what? Is leaf will be true because all the values are same. Okay, and then these four values will be what? Null, right? Because this is the first condition, that if all the values are same, then the leaf value will be true, value will be the value of the grid, and all the four children will be set to null. So for this, all the four values of those children will be null. So this will be the node. This node we will return, and we will add it in the root nodes top left. Okay, so this is how we will proceed. So basically here what we will do recursion. We will in recursion, what we do, we work on the bigger problem, and the smaller problems we will send to recursion. Okay, so basically what I'm trying to say here is, let me just copy this grid. Okay, so what we will do is, right, see, what we will do is, we will check first of all, let's discuss step by step, right? Let's discuss step by step the approach now. Let's discuss the approach now. So I hope you understood the problem. Let's see the approach. So first of all, we will see whether all the values, that is all the values in grid are same or not, because everything depends on this. If all the values in the grid are same or not. Okay, if they are same, we will make a node. For that node, value will be the values which are same. Let's say all the values were 1, so value will be 1. Is leaf will be true because all the values are same, so it will be a leaf, and the 4 children will be null. This is in the case if the grid values are same, but here in this case, if you see, obviously the grid values are not same. Some are 1, some cells have 1, some have 0, then 1 0 0, like that. So in that case, we will make a root node which will have value as any value, 1 or 0, anything you can give. Is leaf will be false because it's not a leaf, right? And for the 4 children, right, for the 4 children, we will divide this grid into 4 parts. We will divide this grid, and we will do recursion, the same step, the same thing we will do recursion for this grid, for this grid, for this grid, and for this grid. So this is how we will approach this problem. Okay, I hope you understood the approach. There is one optimization also to this approach, which we will discuss at the end. Okay, but before, let's see the dry run of this approach. Okay, let's see the dry run of this approach. For the optimized approach, I won't be showing the dry run, that you will do as a task yourself, but I will show dry run for this one because it's important to understand the concept. Dry run you can do by seeing the code also yourself. So see what we will do. First of all, like let's say we have this let's say this is your x axis, and let's say this is your y axis. Okay, and we have to here, since we will check first of all whether all the values in the grid are same or not. So we will start from this 0 comma 0. Let's say this 0 comma 0, we'll start from there. So let's say this is your, here this is your y. Okay, so this is your x, and let's say this is your y. So you will be, let's say we start from 0 comma 0. So what will happen, first of all we will check whether all the values are same or not. Okay, let's say all the values are same or not. So for example, see here, no, all the values are not same, so we will make a node in which, let's say we create a node which value we will set as, let's say 1. You can set 0 also. Is leaf will be set to false. Okay, and this is the second step, this is the third step. Fourth step will be to make a call on see what will be the steps, like let me just write it. So after we check whether the all values are same or not, so if they are same, okay, if they are same, so we'll do different thing. If they are not same, so we will do different thing. So if else will be there, if it's same, else not same. So if it's same, we will make a new node we will make, and we will return that new node, and that node will be having value, let's say all the values are 1, so value will be 1, leaf will be true, and all the children will be false, null. But if it's not same, so that is, in this case all the values are not same, so we make a new node, we will give it value as, let's say 1, is leaf will be false, and for the children, now I will do recursive call. So is for top left, let's see for top left. Okay, for top left, so let's say these coordinates are x1 comma y1. Let's say these are x1 comma y1. Okay, so the coordinates for C, we were initially giving 0 comma 0, that is the starting top left coordinates we were giving of the grid, top left of the grid, that is this is what, top left coordinate, right? Similarly, when we will divide this grid into 4 smaller grids, we will be giving the top left coordinates only in the recursive call. So here top left will be this, then top left will be this, then top left will be this one, and top left will be this one in the recursive call. So basically recursive function will be something like, this is your recursive function. It will be like the root, the current starting point, that is x, then y, and the length as in like how much you have to go. Like for example, in the bigger grid you can go till the whole length of the grid, then since this is now smaller, so your length will be divided by half, because earlier your length was this, now since you have divided the grid, so it will be L by 2 now, the length of this grid, right? So these three will be the parameters in the recursive function. So here see, for this again, if you see now in the recursive call, let's say now we have this grid, just focus on this grid. In this grid now, see, all the values are same. So what we have seen, we will first of all check whether all the values are same or not. If all the values are same, so we will make a new node, and value will be 1, whatever the value is of the grid, value is 1 here, 1 is leaf will be true, and all the children will be set to null, and this node we will return. So for this one, we will return the node, and it will get stored here in the top left of the bigger grid. Okay, this is how recursion will work. Alright, now this was for the top left. Now let's discuss for the top right. Let's discuss for the top right. So for the top right, we have to give the coordinates of this top left corner, right? Like this is the top right grid, but the coordinates we'll give this one, right? So what will be these coordinates if this is x1 and y1? So this will be x, right? x1 comma y1 plus, let's say this is 8, right? So y1 plus 4. Okay, y1 plus 4, because if this is your starting, this is your x on the x only, right? X is this one, this is your x, but y you are going 4 spaces ahead, 4 spaces ahead, right? This is your y axis. So for this coordinate, 4 spaces ahead in this direction, that is your coordinates will be x comma y plus 4. This will be your coordinates for this one. Okay, so in recursive call you will be passing x as this, y plus 4, and length will be what? The total length which was earlier divided by 2, because this will be the total length. Similarly, if you see now for this grid, so for this, right, this is the same case, this is the same case as this one, this is the same case as this one, but this is different. Top right, in the top right values are different, they are not same like these. So again here recursion will help, we will divide it into again the grid, right? So this will be one grid, this is the second grid, third grid and fourth grid. So in this way your recursion will work. Okay, I hope you understood like some, I hope you got some idea about this. Let's see the code once, and it will be better with code. So see, we have this function, right, construct, and we have created this recursive function, helper function, in which we are passing the grid, which we have the initial coordinates 0 comma 0, which we are taking this top left coordinates, top left of the entire grid. Okay, and the grid size, which is the length, that is this one, this length, or this, because this is a square matrix, right? So it will be n cross n, that is the length will be same. So okay, now let's see the recursive function. So as we discussed these steps, first of all we will check whether all the values in the grid are same or not. So for checking that, we have created this function same value, in which we go to the grid, we just iterate in the entire grid, and we check whether all the values are same or not. If all the values are same, we return true, otherwise we return false. Okay, so if all the values are same, so what we did, if all the values are same, we just created a new node, right? So we will create, if all the values are same, we will create a new node. It will have the value of those whatever value is there in the grid, and the leaf will be true. Okay, the leaf will be true. So basically here this node, they are just taking two values. Okay, here they are just taking two values. Otherwise, if the if it's not the same value, okay, that is all the values in the grid are not same, then what we will do, we'll make a root node which will have this is what, one second, let me just close this. Okay, so yeah, we will have this root node in which the this value will be false, and is leaf will also be false, and the all the children we will assign values by doing the recursive call. So in the recursive call, for the top left, let me just close this. So for the top left, right, for the top left, 0 comma the current, let's say this is x1 comma y1, so those will be the coordinates. For the top right, x comma y plus 4 will be the coordinates, that is x1 y1, then x1, this will be y1 plus length by 2, so 4 is what, 4 is 8 by 2, and this is the total length of the grid, the smaller grid, so obviously that will be length by 2. Similar, so in this way you will populate the children. So this is the code. I hope you understood some part of it, and if you are not able to understand, please see the explanation again and try run yourself. Let's understand the time complexity for this. Okay, so see here, time complexity is what, initially what we have a grid. Okay, we have a grid. On this grid, what we are doing, first of all, we are have this function same value, right? For this we are traversing this, right? We are traversing this. So how many calls we are, like how many cells are there for each cell, right? We'll be doing the same, we'll be doing that thing. So it will be n square cells, right? right? And every time the size of the entire grid is getting smaller, right? So if total the size of the grid was like 8 length, like one side, so in the next one it will be decreased by 2, half by divide by 2, right? So that means there will be log of n levels, right? Log of n levels. So initially if grid was 1, now in the next level there will be 4 smaller grids, right? As we saw here, there will be 4 smaller grids, and then there will be 4 more smaller. So there will be what, like for this one again there will be 4 smaller, right? So here let's say if the total cells are, yeah, and for each grid total cells are reduced by 4, let's say, right? But there will be how many calls? 4 calls. So total calls at each level be n square, right? And similarly here, let's say here the total cell got reduced by 8, but since there are 8 calls, there will be 8 calls, so it will be 8. So n square calls will be there for each level, and how many levels are there? Log n levels. So n square log n will be the time complexity for this. Alright, and space complexity will be log n, which is the recursive stack, because here this will be a recursive stack, right? So space, that much space will be taken. So now we will discuss how we can optimize this approach, right? How we can optimize this approach. That's also very important. So optimize. Okay. So if you see here in this code, what repetitive work we are doing. What we are doing. We are, every time we just do, we check, right, whether it has same value or not. This is some repetitive work. Checking same value, if it's same value, because see, let me just quickly paste the tree again. So this grid again. So see, when you check for the first grid, when you check for whether it has same values or not, you go to this entire grid, right? Iterate in the entire grid. After that, when you divide it into smaller grid, again you go to these cells. First, initially for the this whole grid, right? You have gone to each cell. Then for individual smaller grids, you are again going to these cells to check whether they are same or not. This is some additional work, right? Repetitive work. Repetitive. How we can avoid this? How we can avoid this checking whether it's same or not? How we can avoid it? How we can avoid it is, see, let's understand that. So it's a good optimization. Just hold on. So what we will do, right? We will do the recursive calls first. That is recursive calls first. So from recursive calls, we will get the top left node, like node value, top right node value. That is this thing we will get. Oh, sorry. Top left we will get in this one the node value, which is basically the node which is representing this grid, we will get here. Then top right node which is representing this grid, we will get here. Bottom left we will get, that is the node which is representing this grid, and bottom right we will get. So these 4 we will get. Okay, we will get. Now see, now let's say if this grid was all ones grid, was like having all ones. In that case, these smaller grids will be leaf nodes. Why leaf nodes? Because they will have same values, so they ultimately will be leaf nodes, and also they will have same value 1 1 1 1. So value will be 1 for the individual smaller children, and is leaf will be true, right? I hope you understood this, why these children will be, the smaller grids will be leaf. So we will check, right? Once we got these 4 values, we will check whether they all are leaves, right? We will check. Now this is very important, understand guys. So we will check whether all these four are leaf and have same value. If they all have same value and all are leaves, it means the grid, the like the bigger grid was having the same values. So what we will do, we will just return a node having the value as whatever these value is, like let's say 1. And since all the values are, all the smaller grids are leaf and have same value, so obviously this entire grid was also a leaf, right? So leaf will be true. Otherwise, if this is not the case, else just return any value comma false, because it's not a leaf. So with this approach, right, with this optimization, we are only going to each cell once. We are not repeating going again. In that case, time complexity will get reduced to n square. Space will be same, that is log n. So I hope you understood this. Let's see the code for this once. I know it's a tricky problem, but it's very easy if you have understood what they are trying to say. So let me show the code for the optimized approach. So here, see what we are doing. This is a base case, right? If length is 1, meaning that we have one cell. So obviously for that one, the leaf will be true and value will be the value of that cell. Okay. Okay, value of that cell and the leaf will be true. So we will do the recursive calls, and if all the nodes which we get are leaf, right, all are leaf, so if there is a check, if all are leaf and the value of all of them are same, like all the values are same, then we will just simply return a leaf node. We'll make the leaf as true and we'll just give the value which is of these nodes, like 1 or 0. Otherwise, if not the case, then obviously they have different values and all that, so we will just return false, false, and top left, top right, bottom left, bottom right. Okay, here automatically these values will be null because we are not sending anything, right? So automatically the children value will be null. So I hope you understood the problem and the approach, guys. I have tried my best to explain it. Let me know in the comments if any doubt. If you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video. Bye.